Yeah, this is Raghavan from All Force College. Welcomes you for chemistry e-learning classes, e-learning program. So in this session, we are discussing about the first chapter, that is structure of atom. Okay, so we are continuing the same chapter, that is structure of atom. So in the last session we completed, derived the radius, that is equation for the radius of the Bohr's orbit. That means the species containing one electron. And we also derived the equation for energy, and we also derived equation for velocity of the electron in the orbit and number of revolutions made by the electron in any orbit around the nucleus. Okay, we completed all these four derivations. One is radius we completed, energy we completed, velocity completed, and number of revolutions made by the electron around the nucleus in any orbit. Okay, now today let us take up calculation of number of waves, calculation of number of waves in any orbit, calculation of number of waves in any orbit, calculation of number of waves, calculation of number of waves in any orbit, okay, that is a concept for us, calculation of number of waves in any orbit. Okay, that is very important concept for us, and it is very, very simple. Okay, in one sentence we can explain that concept, that is the number of waves made by the electron in any given orbit is always equal to n, that is principal quantum number. For example, the number of waves made by the electron in first orbit is 1 because it is equal to n. Number of waves made by the electron in the second orbit is 2, so that is equal to 2 waves. For example, number of waves made by the electron in fourth orbit, that is equal to 4. Okay, let us calculate numerical there. That means find out the number of waves. Okay, so number of waves made by the electron in a given orbit, number of waves in any orbit, number of waves in any orbit, that is equal to number of waves in any orbit, that is equal to circumference of the orbit by wavelength. Circumference of the orbit by wavelength. Circumference of the orbit by wavelength. That means circumference of the orbit is given by 2 pi r and wavelength, that is lambda. Okay, number of waves that is equals to circumference of the orbit by wavelength. Now remember, according to de Broglie, okay, de Broglie, that means the concept is of de Broglie is not yet started for you people, so but it is, lambda is there, for that purpose only I am taking that concept. Okay, now according to this de Broglie, lambda is equals to h by mv. Lambda is equals to h by mv. Okay, that is a de Broglie equation. Okay, the derivation of this equation and concept of this de Broglie theory, so that we will discuss next. Okay, that is, so now substitute the value, that is lambda in this one. So therefore circumference of the orbit, that is 2 pi r by lambda is h by mv. H by mv. Okay, this is the equation. Now rearranging the terms, just I am not doing anything about this, just I am rearranging these terms. Okay, rearranging these terms. How we can rearrange? So 2 pi, okay, same thing, we are not yet disturbed, by h, okay, done, mvr into mvr, okay, mvr, that's I wanted to show that one, that's enough. So 2 pi, that is just only rearranged the terms in the equation, that's all. So now, according to the angular momentum of electron, so that is, as we know that mvr is equals to nh by 2 pi, okay, this is angular momentum of the electron. So in place of mvr we have to substitute nh by 2 pi, so therefore it is equals to, so that is 2 pi by h. In place of mvr we have nh by 2 pi, okay, so that is nh by 2 pi, okay. Now 2 pi is cancelled and h is cancelled, that is equals to n, okay, that is your answer. That means number of revolutions in any orbit, okay. Let us write here number of revolutions or number of waves in any orbit is equals to the n value, principal quantum number value. Very important concept, you should not forget it, okay. Number of waves in any given energy level or in any orbit, that is equals to principal quantum number, that is equal to n, okay. So this is calculation of number of waves in a given energy level, okay. How we are calculating this? Number of waves in a given orbit or in any orbit, that is equals to circumference of the orbit by the wavelength, okay. Circumference is 2 pi r by wavelength is lambda, we can say. Now, according to the concept of de Broglie theory, de Broglie, he explained dual nature of the particle. Any particle under motion possess dual nature. Any moving particle, any particle under motion possess dual nature. That means particle nature as well as wave nature, okay. That is the concept of de Broglie theory, that we will discuss the details later, okay. Now lambda is equals to h by mv, okay. That means now in place of lambda we have to use h by mv, substituted. Now the terms are rearranged, that is 2 pi r into mv, that I am writing like 2 pi into mvr, okay, by h. So as we know that according to angular momentum, mvr is equals to nh by 2 pi, substitute in this. mvr is equals to nh by 2 pi, done. 2 pi, h, and last remains is n. That means in any orbit, number of waves made by the electron, that is always equal to the orbit number, that is principal quantum number or energy level number. So the concept is clear and it is very, very important, should not forget, okay. Right, the next is, so we completed all the derivation part of this, that is radius, energy, velocity, number of revolutions and number of waves. So all the derivation parts are completed. Now let us take some numerical aspects of these concepts, okay. So now the numericals, let us work some numericals. Okay, some numericals, 5. Let us take the first one. The radius of hydrogen atom is, that means the first orbit of hydrogen atom, the radius of first orbit of hydrogen atom, how much? 0.529 angstroms. We know that. The radius of the first orbit of hydrogen atom, we know, that is standard 0.529 angstroms. Okay, now calculate the radius of second orbit of hydrogen. Calculate the radius of second orbit of hydrogen. Calculate radius of second orbit of hydrogen atom. Calculate the radius of second orbit of hydrogen atom. So the radius of this solution I'll write here. Okay, radius of second orbit of hydrogen is equals to radius of the first orbit, that is 0.529 angstroms into n square, that's all. Simply we have to substitute n square where n is equals to orbit. So therefore we can say 0.529 angstroms into 2 square, second orbit he asked. So it is 2 square, that means 4. Okay, that is 4. So when it is 4, what is the answer? How much it could be? That is 2.12 angstrom units. Like that, very simple. The radius of the second orbit of hydrogen atom is how much? 2.12 angstroms. That is the radius of the second orbit. Okay. Calculate the radius of the second orbit, this much. Okay. Calculate the radius of the third orbit similarly. Radius of third orbit. Calculate the radius of third orbit of hydrogen only. Third orbit of hydrogen atom. How much? That is radius of third orbit. Radius of third orbit in hydrogen, that is equals to 0.529 angstroms into n square, that is 9 into 9, 0.529 angstroms into 9, that is equals to 4.76 angstroms. 4.76 angstroms. Very simple concept, you should not forget, because all these are the important points. That is radius of the first orbit into n square, because it is hydrogen atom. Suppose if the species like hydrogen, okay, species like hydrogen. Let us take one more example on that. Okay, so let us make one question. Calculate radius of second orbit of beryllium plus 3 ion. Second orbit. Calculate the radius of second orbit of beryllium plus 3 ion. So once again, let us revise the concept, that is Bohr's atomic model can explain the atomic spectrum of one electron containing species like hydrogen atom, or ions like helium ion, or lithium 2 plus, or beryllium 3 plus ion, because they should contain only one electron. Okay, so once again, that is Bohr's theory can explain the spectrum of one electron containing species. Okay, so now radius of this orbit we have to calculate. Okay, radius of this orbit we have to calculate, this one. So this is first one we have done, this is second one. Now coming to the third one. Okay, so third one, calculate the radius of the second orbit of beryllium plus 3, second orbit of beryllium plus 3. So the concept, radius of nth orbit is equals to what happens? 0.529 radius of nth orbit, okay, in beryllium plus 3, that is equals to 0.529 angstroms into n square. Okay, fine, n square by z, by atomic number of the species. Okay, now that is the formula we have to use, that is 0.529 angstroms into n square. Which orbit? Second orbit, that is 2 square. 2 square means it is 4. Okay, by z, atomic number of beryllium is 4. So it is 4. Now 4 is a 4. So therefore the radius of the first orbit of beryllium plus 3, second orbit of beryllium plus 3 is equal to the first orbit radius of the hydrogen atom, that is 0.529 angstroms. What we can mention in this? That means the radius of the hydrogen atom the radius of hydrogen atom, we can also expect the question like this. The radius of hydrogen atom is equal to the radius of the species. Okay, options you will find. What is the answer? Is equal to the radius of second orbit of beryllium plus 3. That means radius of hydrogen atom is equal to the radius of second orbit of beryllium plus 3. Done. Okay, you got it? The concept, is it clear to you? Because it is all simple to understand. See, understanding the thing is very easy, simple, but you should remember the concept properly, and when you find the question you have to explain, that is, you have to apply your skills. That is very, very important. The skills, the application skills are very important. Okay, so understanding, see, the students, depending upon their capacity, they can understand easily. Okay, but application skills are different. Okay, so that we have to develop. So the radius of the hydrogen atom, that is equal to the radius of second orbit of beryllium plus 3, like that. So this is the formula, that is to calculate radius of nth orbit of species containing hydrogen. Okay, species like hydrogen, that is 0.529 into n square by z. That is the concept of radius. Okay, now let us see. Okay, these are the radius numericals. Let us work on energy numericals. Okay, energy numericals. Okay, let us remove this. Energy numericals. What is the equation for energy of the electron in the orbit? Energy of electron in the nth orbit. Okay, that energy of the electron in the nth orbit, that is equals to minus, what is the energy of the electron in nth orbit? Energy of the electron in the nth orbit, that is equals to minus 2 pi square m z square e to the power 4 by n square h square. N square h square, that is the formula for us. Okay, now energy of the electron in the first orbit of hydrogen, energy of electron in the first orbit, okay, first orbit of hydrogen, that is equals to how much? 13.6 electron volts. This we know. Okay, what is the energy of the electron in the second orbit of hydrogen? Okay, calculate. So energy of the electron in the second orbit of hydrogen, that is equals to energy of the electron in the first orbit, okay, by n square. For nth orbit we have to use, that is energy of the electron in the nth orbit is equals to minus energy of the electron in the first orbit by n square. Okay, so by n square means in which orbit? So second orbit, that is 2 square, so 4 by 4, that is equals to how much? That is equals to minus 3.4 electron volts. 3.4 electron volts. Okay, you got it? So what is the energy of the electron in the second orbit of hydrogen atom? So that is, sir, it is very simple, divided by n square. Okay, by n square. So calculate one more. Calculate energy of the electron in the third orbit of hydrogen only, that is equals to minus 13.6 electron volts by, come on, 3 square, that is n square by n square. N is equals to what? 3, third orbit, 3 square means 9. That is equals to minus 1.51 electron volts. This is in hydrogen atom, first orbit. This is in second orbit. This is in third orbit. Okay, like that we can calculate energy of the electron in the first orbit, second orbit and third orbit. Okay, now we can also explain like as the number of orbits increases, size of the orbit increases. First orbit, how much? 0.529 angstrom. Second orbit, that is into n square, that is 4, 2.12 angstroms. Okay, just now we explained that. First orbit, second orbit, third orbit. What is the radius of the first orbit? 0.529 angstroms. Second orbit, 2.12 angstroms. Third orbit, what is the radius of third orbit? That is 4.76 angstroms. Okay, we explained that all. That is, as the number of orbits increases, the size means radius increases. Got it? Now, energy of the electron in the first orbit, how much? 13.6 electron volts minus 13.6 electron volts minus. Second orbit, minus 3.4 electron volts. Third orbit, minus 1.51 electron volts. As the number of orbits increases, size increases, energy also increases. You can see clearly it is minus 13.6, so the negative decreases. So minus 3.4, it is minus 1.51. So therefore, as the number of orbits increases, size increases, energy also increases, but what we said? But energy difference between successive orbits gradually decreases. Energy difference, that means gradually decreases. What we explained there, that is the difference between E2 minus E1 is much greater than E3 minus E2. Okay, it is much greater than E4 and E3. Okay, we already mentioned that. Let us see some. So E2, that is minus 13, that is 3.4. So what is the difference between these two? That is E2 minus E1, that is equals to 10.2 electron volts. It is greater than the difference between, that means it is greater than energy difference. 13.6 minus 3.4, it is 10.2. It is greater than this difference. This difference is approximately, it is 1.9 something. Okay, so that is, it is greater than 1.9. That means as the number of orbits increases, size increases, energy also increases, but energy difference between successive orbits gradually decreases. Energy difference between the successive orbits gradually decreases. That is the point I wanted to mention in this. Okay, now we know how to calculate energy of the orbit in hydrogen and species like hydrogen. That is over. Next, energy of the electron in the hydrogen atom we can calculate like this. We can calculate like this. What is the ionization energy of hydrogen? Sir, in hydrogen atom the electron is present in the first orbit according to the configuration. Okay, done. Then how much energy we have to supply to remove that electron? Yes sir, this much energy is supplied. That is, when this ground state electron, by getting 13.6 electron volts energy, the electron is once forever, it is removed from the infinity orbit. That is called ionization energy of hydrogen atom. Okay, so this is nothing but energy of the electron in the first orbit. That is nothing but ionization energy of that first electron in the orbit. Okay, what is ionization energy of hydrogen atom? 13.6 electron volts. Okay, done. Okay, now let us see what is meant by ionization energy. The amount of energy required to remove an electron. Okay, so let us experience with some different numerical. Right, next one. Okay, I'll give the problem. Okay, substitute the data clearly, then you do it. Okay, the calculations we can do it later, right? Whenever you find the time, you can solve it. Question is, calculate ionization energy of beryllium plus 3 ion. Calculate ionization energy of beryllium plus 3 ion. What is the reference? So the ionization energy of hydrogen atom is how much? That is given as minus 13.6 electron volts. It is given. He is asking you to calculate this. Okay, ionization energy of beryllium plus 3 is equals to energy of the electron in the first orbit of hydrogen, that means ionization energy of hydrogen, we can say like this, ionization energy of hydrogen into Z square, that's all, simple, sorry, into Z square, correct, okay, into Z square, therefore minus 13.6 electron volts into Z square, atomic number of beryllium is 4, that is 4 square. You got my point? Okay, because energy and this is orbit, and orbit number is inversely proportional. So it is the amount of energy required to remove the electron, because that electron is present in the first orbit only. It's not somewhere else. It's present in the first orbit. So into Z square. Is it clear? Okay, once again let us see. Calculate ionization energy of beryllium plus 3. Okay, what data is available? Ionization energy of hydrogen atom is available. Okay, so ionization energy of beryllium is equals to ionization energy of hydrogen atom into Z square. Okay, like that. One more practice. Okay, calculate ionization energy of lithium 2 plus. Same, in the same problem. One more I am adding here, that is lithium 2 plus. Ionization energy of lithium 2 plus, that is equals to minus 13.6 electron volts into Z square. Okay, Z square means lithium atomic number is 3 into 3 square. Okay, like that. That means into 9. So like that we can calculate. Okay, so how much it could be? So for lithium plus 2, that is into 9. How much it is? 13.6 into 9. So that is 122.4 electron volts. Okay, and how much in this? It is given, how much it is? 54.4. It is 54.4. Okay, that is electron volts. Okay, so this much of energy is required. This much of energy is required to remove the electron. Okay, from beryllium plus 3, and so it's not 54, it should be more than that. Okay, that is into 16 it comes. Okay, so right, like this we can calculate ionization energy of the species. Okay, now let us work out some more numericals on this. Okay, so some more numericals. Let us write ionization energy for helium. Ionization energy for helium ion is, ionization energy for helium ion is 1.96 into 10 to the power 1.96 into 10 to the power minus 19 joule per atom. Joule per atom, this much. That is ionization energy of helium plus ion is how much? 1.96 into 10 to the power minus 19 joule per atom. Okay, calculate the energy of first orbit of beryllium plus 3. So calculate ionization energy of beryllium plus 3. Calculate ionization energy of beryllium plus 3. Calculate ionization energy of, calculate IE of beryllium plus 3. That means first orbit is present in the first orbit only. Calculate energy of the electron in the first orbit of beryllium, means that is nothing but ionization energy of beryllium plus 3 ion. Okay, that is the data is available. So instead of giving, okay, now let us take up ionization energy of helium plus is equals to what we can understand. The normal meaning, ionization energy of helium ion, that is equals to, that is ionization energy of hydrogen into n square, into z square, we know that, that is into z square. Okay, z square for helium, that is 2 square, that means 4. That means the ionization energy of helium is equal to the 4 times of ionization energy of hydrogen atom. It is clear. Similarly, ionization energy of beryllium plus 3, that is equals to ionization energy of hydrogen into Z square, beryllium atomic number 4. 4 square, that is 16. That is 16 times. That is ionization energy of beryllium plus 3 ion is 16 times that of ionization energy of hydrogen atom. Okay. Now, that is ionization energy of beryllium plus 3 is equals to, he has given reference is helium, that is 1.96 into 10 to the power minus 19 into Z square means 16 by 4, that is equals to, it is 4 fours are, that is equals to 1.96 into 10 to the power minus 19 into 4. So how much it comes? That is into 4. Okay. That is 7.84 into 10 to the power minus 19, which is joule per atom. Joule per atom. Okay, this is ionization energy of beryllium plus 3, 7.84 into 10 to the power minus 9. Okay, so now we completed some examples of ionization energy we have done, and still more numericals to be done on number of revolutions and number of waves made by the electron in the given orbit. Okay, so that will take it in the next session 14th. Okay.